Initially, there is no flow of water in the flow sensor. In display, we are getting no flow detected. Now we will fix the flow sensor to the tap and will make the flow very less rate. Now it is showing in display 24 liter per hour. Now we will increase the flow rate. So it is showing 56. Still we increase. It is showing 80, 112 per liter. Further, with high speed, it is showing 200 liter per liter. So in this way, we can find the flow rate of any liquid or water or anything used with the help of flow sensor. In this experiment, we are interfacing flow sensor. The model number is YFS201 with Arduino UNO board. This is the image of a water flow sensor and which is interfaced with Arduino UNO board. And in order to display the whether the flow rate is detected or what is the flow rate, for that purpose we are using LCD module also. And behind this LCD module, there is I2C module which is connected to the LCD module. So these are the images of flow sensor. And this is the top view, bottom view, and the wires used for connecting, for doing connection. And it has got two inlet and outlet, one for water inlet and another one for a water outlet. So you can connect the tap on one side and water pipe on other side. And this YFS201, it is a type of flow sensor. It is designed to measure the fluid, typically the water flowing through the system. These sensors are commonly used in applications like water heater, water dispensers, industrial system, irrigation system, wherever the monitoring and control of the flow water is essential. And I'll explain the working principle of flow sensor. The module is YFS201. It operates on the principle of Hall effect, and so it is called as Hall effect sensor. It has got a small pedal wheel inside the sensor housing. Whenever the water flows through the sensor, the paddle wheel inside the housing, it starts rotating, and one magnet is attached to the paddle wheel. Whenever the water flows through it, the paddle wheel passes by the Hall effect sensor and it generates the pulse. And the frequency of the pulse depends on the flow rate of the water. If the flow rate is very slow, the frequency is less. And if the flow rate is very, very high, the frequency is also high. So the frequency of these pulses is directly proportional to the flow rate of the water. So in order to convert the pulse frequency into flow rate, that is in physical units like liter per minute or liters per hour, the sensor requires some calibration factor. So this factor is specific to the each sensor, and it may be provided in the sensor data sheet. So if you refer the sensor data sheet, you will get the calibration factor. And the output of YFS201, it provides the digital output in the form of pulses, and each pulse represents a certain volume of water passing through the sensor. So this sensor, when it is connected to your microcontroller like Arduino UNO or Node MCU, the microcontroller starts counting the pulses over a period of time and applies the calibration factor in order to calculate the flow rate. So this is all about the introduction of flow sensor. In short, I'll explain the code of this water flow sensor. These two include the library file required to display the flow rate in a LCD. So before uploading the program, you should include LCD Crystal I2C library file. To install this library file, you have to go to Sketch and include library. Under that, manage library. So you type here liquid crystal. I2C you should type. So I have already installed. I'll show you. See, this I have installed, Liquid Crystal I2C by Frank D. Brabender. So this I have installed. So before this, you should install this. So in this line, we are going to give the I2C address, that is 0x27. Most of the I2C modules use this address only. And the second parameter defines the number of columns and the number of rows. So it means that you can display 16 characters in 2 rows. Okay, then this one, flow frequency. So in order, we are declaring a variable flow frequency in order to measure the flow sensor pulses. And to calculate the flow in liters per hour, we are using some variables like volume, flow sensor, and this is important. The flow sensor signal pin, it is connected to the Arduino UNO board. Here we are connecting the signal pin to the pin number 2 of Arduino UNO board. Okay. So after this, so that flow sensor, we are making it as input variable because it is giving the value to the Arduino UNO board. So you make it as input variable using the command pin mode. Okay. Then these are all the parameters for defining the LCD. LCD begin, LCD init, in order to make the backlight on, LCD dot backlight. So many functions also we are using it. So after I want to display whenever there is no flow of water, no flow detected. For that we are printing in LCD dot print no flow detected. If the flow is detected, we will print the message flow rate in terms of liter per hour. If there is no flow, we will display no flow detected in the LCD display. Then after writing this program, you select the board. The board selected is Arduino AVR. Under Arduino AVR board, you select Arduino UNO, and you select the port. The port selected is COM3. Now you upload the program to your Arduino UNO board. Okay, now the compiling is done and it started uploading the program. The uploading is also done. Now we will check the output. This is water flow sensor. It detects the flow rate of water. It has got 3 wires. Red is VCC, black is ground, and yellow wire is signal pin. So the red wire, it is connected to the VCC pin on red board. This line I have used as VCC, and this line I have made the connection for ground. And from this water flow sensor, the VCC pin is connected to VCC on the breadboard, and this black one is a ground pin. The ground is connected to the ground on the breadboard, and the yellow wire, it is a signal pin. And in program I have used pin number 2 of Arduino UNO board, so it is connected to pin number 2 of Arduino UNO. So this is the connection diagram for the water flow sensor. Next, to display the whether flow is detected or not, I have used LCD, and along with this I2C model. So backside I have connected I2C model. So I2C has got 4 wires. So VCC, first one is ground. From this side it is ground. It is written on the I2C model. You can check it. First one is ground. Second one is VCC. And the third one is SDA. And the last one is SCL. So SDA stands for serial data. SCL stands for serial clock. So the first one, ground, it is connected to the ground pin on the Arduino breadboard. And the second one is red, this is VCC pin, it is connected to VCC on the breadboard. And the third one is SDA. So the SDA is connected to SDA pin of Arduino UNO board. And the last one is SCL, serial clock, it is connected to the last pin of Arduino UNO board, that is SCL. So this is all about the connection diagram. You can check in the serial monitor. No flow is detected, is displayed here. So it is displayed, no flow detected. Initially there is no flow of water in the flow sensor. In display we are getting no flow detected. Now we will fix the flow sensor to the tap and will make the flow very less rate. Now it is showing in display 24 liter per hour. Now we will increase the flow rate. So it is showing 56. Still we increase. It is showing 112 per liter. Further with high speed it is showing 200 liter per liter. So in this way we can find the flow rate of any liquid or water or anything used with the help of flow sensor.